Hello everyone. The coronavirus is a global pandemic affecting everybody in the world. Now more than ever, maps are essential for decision making and staying informed about this global threat. In this video, I'll show you how you can make your own coronavirus maps using free, reliable, and open source data, as well as free and open source mapping tools. Now more than ever, maps are essential to handling the global pandemic that is the coronavirus. We're constantly seeing maps in the media and other official sources that are being used to inform communities about how this global threat is spreading around the world. I wanted to make a relatively quick video to show people that may be new to mapping how they can create their own maps using free, reliable data sets as well as free and open source mapping tools. If you're an existing GIS user, I think you'll find this lesson helpful for understanding how you can make maps. If you're brand new to mapping, I hope that this video will give you some background on important mapping concepts related to mapping numerical data as well as using maps in general for communication. If you like this video, please share it. Please give me comments, subscribe to this channel, and anything else you can do to help make the power of maps available to people around the world. All right, let's get into this lesson. Hello everyone, and welcome to this lesson on how to create coronavirus maps with free tools and data. To give you an overview of what you'll learn in this lesson, I've created this lesson for people that may want to create your own maps of where coronavirus cases are happening. The intended audience are people that may be new to using digital tools to make maps. However, if you're an existing Geographic Information Systems or GIS or digital map maker, you may find some of the tips, especially on data sources, useful. If you are new to making digital maps, the lesson does assume you have some background knowledge working with computers and information technology or IT skills, such as downloading files, working with files, and so forth. These are fundamental skills you'll need in order to be successful with this lesson. I'll first review some basic map concepts if you're new to actually making maps, especially coronavirus maps, which work with numerical data. I'll then give you some quick hands-on demonstrations of how you can go about making coronavirus maps using free and open source tools and data. And I'll give you plenty of resources for more advanced analysis and follow-up work if this is a new area for you. The following is a summary of the tools and data that I'll use in this video. All of the tools and data sets can be accessed through links that I'll provide in the video description, so just look below so you can see where you can find all of these resources. Some of these tools you're probably familiar with. I'll use Google Chrome. I'll use the open source tool OpenOffice Calc, which is similar to Microsoft Excel. I'll use a common zipping tool called 7-Zip that's also included with Windows. And I'll use the well-known open source GIS tool called QGIS to do the actual map making. Data sets that I'm going to use come from the Humanitarian Data Exchange, the Coronavirus Cases data set. And again, links are provided for that. I'll also use the World Bank country boundaries for some reference and context to create a background layer in terms of showing coronavirus cases and world countries. And I'll also briefly introduce OpenStreetMap data that you can access inside of QGIS, again, to be used for background and context. Before I get into a hands-on demonstration of actually making some coronavirus maps, let's take a look at the state of coronavirus maps as of March 2020 when I'm making this video. We're seeing a lot of maps that are used to show confirmed cases, numbers of deaths, people infected, and so forth. Often these maps are being showed at the world or country scale, and there's different ways that data, specifically numerical data, is being presented on maps. In this example, this is from the Center for Disease Control in the United States that shows a world map of pandemic cases as of March 20th, 2020. Make note of the colors used to highlight countries and also something called the map projection that I'll talk about in just a minute. Here we see another map from the CDC. Because it is an organization from the United States, it's showing coronavirus cases at the country level inside the United States. Here is a map that I quickly made when developing this lesson to show you what's possible with using free and open source tools and data. And you're seeing a lot of coronavirus maps that look similar to this one. And we'll talk more about the design of these kind of maps in just a moment. Let me first go over some basic map concepts if you're new to making maps that contain numerical data. First off, we'll take a look at the idea of map projections, as this is very important to how your data will look in terms of shapes of countries and other what you might call enumeration units on maps. Another topic I'll touch very briefly is classification. This is really important for how numerical data is actually presented in terms of classes. And I'll also touch briefly on colors and display. First up, map projections. The idea of a map projection is when you take a three-dimensional surface like the Earth or a globe and you flatten it out. A lot of common online digital maps, such as the popular Google Maps, use this type of map projection called the Mercator projection, or a variation of it. Note how Greenland and Antarctica look very large and so forth. You're seeing a lot of coronavirus maps at the world scale that are presented using this map projection. Just make note of the distortions that this map projections create. Another way that you can present data at the world scale with map projections are using other kinds of projections, what are known as equal area. Whereas in this example that I just highlighted, note how Africa, South America, North America, Asia, and so forth are shown with the proper area. So looking back at this map from the CDC that I showed earlier, note the use of the map projection in terms of how it distorts sizes, shape, and so forth in terms of showing data at the world level. Another really important idea that I won't have time to go into a lot of detail with is the idea of data classification. In this example, I'm showing the population of countries in Africa. It's all the same underlying data, but it's been classified into 5 different data bins. And each of the data classification methods have different ways that the data looks when presented on a map. Starting on the left is the equal interval classification. Make note of the legend of the 5 categories of classes that are used. The basic idea is that the population of a given country is assigned to one of these 5 data classes and then assigned the corresponding color. In the equal interval classification, data values with high outliers are more prominent. The country Nigeria has the largest population in Africa when compared to other countries. Make note of the legends in the other 2 types of representations that are used. Again, it's all the same data, and it just looks different depending on how you classify it on a map. This is going to be a very common thing with coronavirus cases and other numerical data that are shown in spatial units, such as countries, states, counties, or whatever administrative level you may map data at. I'll provide cards on this video where you can learn more about these concepts. So if I go back to this coronavirus case map, when we look at it again, note the legend how the different classes, in this case 8 different classes, have been assigned to show reported cases in the United States. From none, values ranging from 1 to 5, and others that range from 1,000 to 5,000. So a lot of variation can be done based on how you simply just classify the data. Another important concept about mapping numerical data in particular are the colors and how you display the data. This graphic shows the idea of visual variables, or visual devices that are used for presenting data on maps. For showing coronavirus data, pay particular attention to the ideas of color, hue, and lightness. For example, when you're showing quantities of data, you may go from a lighter shade of one color to a darker shade of another color. Again, if we revisit the CDC map and take a look at the legend, notice how the colors are going from a light shade of almost a yellow to a darker shade of brown to indicate the magnitude or quantity of cases that are being shown, and as per the data classification scheme that's being used on this particular map. In this map that I'll show you how to make later in this lesson, I'm using what's called a graduated symbol representation. Make note of the legend where I have a green circle that changes its size based on the quantity of the data being presented. This is very commonly being used in showing coronavirus cases. And as you look at more maps of coronavirus cases being published by the media, you'll often see this kind of representation. So it's important to understand how it works and what it's representing. I next want to talk about the most important aspect of any mapping activity is finding good and reliable data that you can then create maps from. I can't say this more clearly and more directly. When you are working to create coronavirus maps, you must use data from a reputable source. When I was creating this lesson, I looked on the internet and found a couple of sources I would consider reputable. The one that is being used the most is perhaps the World Health Organization, where many media sources are getting their data from. In particular, the World Health Organization is publishing a daily situation report that gives important data and statistics on the global situation with coronavirus. I'll provide a link to where you can find these data sources in the video's description below. I'll talk briefly about another data source I found. This is from the European Union and their Open Data portal. Open data is the idea of data that is freely available to anybody that wants to use it. And in this case, the EU is a reputable source, and you can download their geographic distribution of COVID-19 cases. For this video, though, I'm going to use data that I've downloaded from the Humanitarian Data Exchange. This is a data source I've used often for other projects, and it was the first place I went to look for to find novel coronavirus case data. And sure enough, they have very good, reputable data that is being published by Johns Hopkins University and is published under a Creative Commons attribute license, making it freely available to anyone. In the hands-on demonstration part of this video, we'll go through downloading and working with data and creating maps from it. I also want to mention another good data source to get for making corona maps, especially at the country or world level data, are the boundaries of countries. And when doing some research for this video, I found a wonderful data source through the World Bank that's reputable and also freely available under a Creative Commons or CC BY 4.0 license. And again, links to these data sets are available in the video description. So here are the steps to create a coronavirus point map. I'll go over each step as a summary, and then we'll dive into a hands-on. So you first want to go and download and unzip your data sets. We'll take a look at the coronavirus data sets in OpenOffice Calc, an open source tool that's similar to Microsoft Excel. We'll bring the data into QGIS, which is an open source GIS tool. We'll add a base map for context, and I'll show you how to do that with the world countries boundaries from the World Bank I just talked about, and I'll also show you how to connect in what's called OpenStreetMap. Then we'll convert latitude and longitude points contained in the data to map points. We'll then create a graduated symbol representation using classification schemes like I talked about earlier. And then as an optional thing, we can modify the projection of the map to make it more suitable for showing data at the world level. I'll then show you the basics of how to create a map layout or final product that you can export. All right, let's get right into the hands-on then. To begin the hands-on, we're going to download our data sets. What you're seeing here is the Humanitarian Data Exchange webpage that has the novel coronavirus 2019 cases. I'm going to download the time series CSV or comma separated file. I'll click here on the download button, and I'm going to save it to an easy to find directory, ctemp, and it's a comma separated file. Over here, I have the World Bank official boundaries, and again, links to all these data sets are available in the video description. And I'm going to click on the tab that says Data and Resources, and I want the world country polygons very high definition, and I'll click Download here. And it's going to give me a zip file, and again, I'm going to put it in the same directory, ctemp. And let's go take a look now at these data sets. For step 2, I'm going to take a look at my data using OpenOffice Calc, and I'm going to right-click, And because I'm emphasizing free and open source tools, I'll use OpenOffice Calc. And you're going to have to do an import here on this. So you want to say it's separated by a comma, and you'll see how the data starts to create its shape. And you can see here, this is a really wonderful data set. They've given you the country level and then a sub-level below that as need be. So if I look through some of this, Western Australia, here I can see states within the United States. Also make note of this, Diamond Princess and Grand Princess. I'll come back to that later. Now, a really significant thing about this data set too is the fact they give you a latitude and a longitude column. And we're going to use that data to create point representations. And what they have in these columns are the numbers of cases by each day reported. And if you scroll to the very end, they're up to now March 21st when I'm making this video. You actually don't really need to do too much to prepare this data set, but it's important to be able to look at it in another program and if you want to do other kinds of analyses. Okay, in this next step, we're now going to bring the data into QGIS. I'm assuming that you've already downloaded and installed an open QGIS, and this is what the software looks like. To be clear, I don't have time to do a very thorough, detailed demonstration of everything about QGIS. It is a somewhat complicated software package. I'm just going to get right down to business of making a map. And there's plenty of resources on the web that I'll provide if you need to learn more about other aspects of this software. So I'm going to create project, a new project, and I'll save my project first in my same directory, ctemp. I'll call it Corona Demo. And the first thing I need to do is bring my data in. So if I go back to the data I downloaded, I'll first go and grab the world country boundaries. If I right click, I have to unzip those out. And inside of the folder I get from unzipping, this is what is called a shapefile in the mapping world. If you're familiar with GIS, you know all about shapefiles. The quickest way to get the shapefile in is you want to click on the SHP file. You can drag it and drop it into the QGIS table of contents here on the left and so forth. There are other ways to add data besides that. You can click layer, add layer, and so forth. But again, don't have time for that. This is a quick demo. So this gives us a background and a context. Now you may also want to add a different base map to your map, and there's something called OpenStreetMap that works really good for that. And the way you can get OpenStreetMap is to go to this menu here, Plugins, Manage and Install Plugins. And you want to look for a plugin called Quick Map Services. And go ahead and install that. And then make sure it's turned on, the checkbox. And that'll give you a menu that looks kind of like this, Quick Map Services. And then look for OSM and then the OSM standard. And although it's not lining up perfectly with the World Bank data, when you zoom in, well, it looks a little better now. If I turn that off, you can see that you get sort of a Google Maps type thing. Again, if you're new to mapping, OpenStreetMap is the world sort of premier open source data, and it can be very useful for giving context, okay? So I just mentioned that there, but we're gonna mostly use this as our background. And again, real basics with QGIS, you can click layers on and off and so forth by checking their visibility. Now let's bring the coronavirus data that we downloaded from the Humanitarian Data Exchange into QGIS. And the way I'm gonna do that is to go layer, add delimited text layer, and that's because it's a CSV file. And in this dialog, I want to go to file name. I want to go to my directory I downloaded, the time series CSV. I want to open that. And now it's point coordinates, and the X field is going to be longitude. And Y field is going to be the latitude. And that's why this is such a wonderful data set, is because they're giving you basic point reference right in the data set for just this kind of thing. And really don't worry about any of the other things. Just hit add. And there you go. So you now have coronavirus cases from around the world from a reputable source that you can start to make maps from. Let me show you a little bit more about what you can do here. Let's create a basic graduated symbol representation. If I go to this layer, again, if I uncheck that, I'll toggle the visibility, right click and do open attribute table, you'll see the underlying data associated with each point. And it's a time series, so March 21st, so forth, by spatial unit. So what I can do is if I right click, go to properties, in this dialog I want to go and click on the Symbology if it's not already clicked on, and then I want to click here, make it graduated, and the column will be whatever. You can only do, in this example, I'll only do one date at a time. I'll do the most recent one, March 21st, the day I'm making this video. And down here, you'll see what I talked about earlier in this lesson about the different modes of classification. I talked about equal interval. I've got a couple other ones. I'll do equal interval. I'll hit classify. And I'll change the method from color to a size. And it looks a little unintuitive at first, but you can see here are the different classifications I've used for this data. When I hit apply and then OK, you can see now how the points have changed different sizes. So we've all been hearing about how Italy has been suffering the most from coronavirus cases, and hence the number of cases is the largest in terms of the circle that's shown. And you can see the legend that's coming up here in the classification. Now, this is showing data at the whole entire world level. So by comparison, using equal interval, clearly China has the most number of cases in general, and in this data set, they actually do break it down by other cases. One other tool that can be handy is the Identify tool. And if you click on a point, you can see this is the Qinghai province of China and so forth. Now, just to mention, if you did want to make a different projection of the world to show this data, to do that, you can click down here. And again, this is probably a little bit more of an advanced topic, but just to make you aware of it, a real popular one that used to be used even by National Geographic was the Robinson. So if you do World Robinson, it's very good for showing the world. Don't worry about these little display artifacts. That's just with the software. When you zoom in on Europe, it'll go away. Let's say we want to make a map of Europe, coronavirus cases. And one of the first things I'll do is some basic cartographic design. I'll use a lighter background to show these points. So to do that, I'll go to the world countries, and I'll keep it as a single symbol, simple fill, and I'll make it a very, very light gray color. And you can see how that visually creates a little bit more contrast. Now you have other things you could do. I might recommend, if you're showing this last legend class is showing that big outlier in China, you might remove that right from your legend display if that's what if you're focusing, say, on Europe. And you might want to rename it and you could possibly do some labels that could also help. If I go here, back, right clicking, go to labels. If I put a single label, now I could pick one of the columns from this data set. Maybe I want to show the numbers, for example. And that might help give a little bit more clarity to the legend and so forth. You could also perhaps change the labels to show the name of the country. And cartographically, this isn't very pretty because of all the overlapping, but again, if you're trying to make quick maps to show what's going on, this could be sufficient. Now, to make an actual layout, if I go here to Project, New Print Layout, this is how I design it. Notice how this looks like a piece of paper, and you get some controls. The first thing you want to do is add the map. And in this case, I'll fill the whole entire page out. And I might change the scale of the map, and I can also move the map. If I click on this button here, move the item content, I can pan things over, because what I'm going to do for my design is I'm going to use this white space over here to put my legend and so forth. And to do that, I'll go add item, add a legend. And over here, some of these things I don't want to have in the legend. I don't need to have the country boundaries. So if I uncheck auto update and then click on that item and remove it, and I'll remove that. And notice how that is modifying the legend and so forth. And I can add other items if I add a label. And I can change its appearance around and so forth. I'm not going to go into very much detail with all these kind of small detail items, but you get the gist of kind of where I'm going here. And of course, you can add a scale bar and other things. And then once you're happy with the way your map looks, you can then, of course, you want to save it. You can export it out as an image. And you get a graphic that you can use depending on what your needs are and so forth. I also want to briefly mention another important topic with mapping numerical data. That is the idea of data normalizing. In the previous examples, I showed you how to create maps of the raw counts of coronavirus cases, basically the number of cases in a given country. Although this technique can be useful for just getting a sense of how many cases there are, if you get into more advanced mapping, you're ultimately going to want to normalize the number of coronavirus cases in relation to some other variable of interest. These maps briefly demonstrate the idea of data normalizing. In the top map, you're seeing the population of people that are aged 55 to 64. These are basically just being shown as raw counts within each spatial unit. However, the map on the bottom is showing the age of people 55 to 64 as it relates to the overall population within each spatial unit. Notice how the presentation of the data is much different because you're showing the population from 55 to 64 as a percentage within the bigger population as opposed to just the count of people that are within that age group. Data normalizing will be important if you're going to map coronavirus cases to get a better comparison between different spatial units. For example, comparing one country to another or one county to another in terms of the percentage of the overall population that has coronavirus as opposed to just the raw counts of cases. So where do you go from here? I encourage you to start creating maps for your country. Use the data sets I've shown you in this video and other resources to start mapping coronavirus cases for your particular country to help inform your government, your community, and anybody else that needs the important information that maps contain. Start creating maps at the subnational level. Using the United States as an example, create coronavirus case maps at the state level, the county level, the town level. This could become very important given the projection in the number of cases that are expected to rise over the next year. Incorporate other data sets. Show how the virus is in relation to the locations of hospitals, schools, vulnerable populations. Contact me directly if you have any questions on ideas on how to make maps that incorporate other data sets. And like I've said, see the video description below to find more free data sets you can use. Thanks for watching this video. I hope you found it useful and get you started with mapping. Again, please share this video, like this video, add any comments, and contact me directly if you have any questions or comments or want additional videos on the topic of creating coronavirus maps. And just remember, these are real people and real lives in these maps that you're creating. So keep that in mind and keep that as a motivation as you create maps that can help with the coronavirus. Thanks for watching.